Welcome back, everyone. So in the last video we basically learned how to take the average of something, and to do so, just a quick review, you add up all the numbers and divide by the number of numbers. Divide the total addition of all the numbers by the total number of numbers. Okay, so on to question number 5, which is another story problem. So you can obviously see that you'll need to master these for the ACT. And I've written it out right here. It says the oxygen saturation level of a river is found by dividing the amount of dissolved oxygen in the river water currently has per liter by the dissolved oxygen capacity per liter of the water, and then converting it into a percent. If the river has 7.3 milligrams of dissolved oxygen per liter of water, and the dissolved oxygen capacity is 9.8 milligrams per liter, what is the oxygen saturation level to the nearest percent? Okay, so upon first reading this, it seems very difficult. I mean, you have all these terms: saturation level, oxygen, milligrams. I mean, what does this have to do with math? What does this have to do with math? But that's some of the trick on the ACT, is it'll always give you the information you need. So we remember our story problem strategy, and that's to always figure out what it's asking for first. So it says, what is the oxygen saturation level? And if we look back in the problem, we can it'll tell us how to find that. It says the oxygen saturation level of a river is found by, so it's going to tell us how to do it, dividing the amount of dissolved oxygen, and then right here we see 7.3 milligrams of dissolved oxygen. So we have 7.3 milligrams of dissolved oxygen, and it says divide the dissolved oxygen level by the dissolved oxygen capacity per liter, and right here it says dissolved oxygen capacity is 9.8. So it's just a simple division problem, which seemed very difficult is very easy when you just pick it apart. So now we just use my calculator here. 7.3 divided by 9.8, which is equals 0.744. But now it says, we're not done yet, we need to look at the last thing. It says to the nearest percent. So to change any number into a percent, you just multiply it by 100, which is, so 0.744 times 100 is equal to 74.4%. And then to the nearest percent, you just round, so that's 74%, and that's the answer. And since we still have quite a bit of time, I'm actually going to start doing 2 questions per video, just 2, so I don't have to upload as many. So we'll go on to question number 6, I believe. Yes, question number 6. Okay. It says a rectangular lot that measures 150 feet by 200 feet is completely fenced. What is the approximate length in feet of the fence? So it's a rectangular fence, so it sometimes helps to draw a picture if you can't really get the image down in your head. So it's a rectangular fence. Pretend these are all straight edges, and one side is 150 and the other side is 200 feet. And since it's a rectangle, opposite sides have equal length. So this side is 150, this side will also be 150. This side is 200, this side will also be 200. And it wants to know what is the approximate length of the fence. So the length is just this outer part right here, the perimeter. And to find the perimeter, you can just add up all 4 sides. 200 plus 200 plus 150 plus 150 is equal to 700. So the length of this fence is 700 feet, which is the answer. And that's all the time I have for this video. I'll see you in the next one.